This is a problem that trips up a lot of students. It can be kind of a challenge depending on the shapes of the graphs. If I'm just given curves and I'm not given really any information, and I'm told that one of them is position, one of them is velocity, and one is acceleration, which is which? You're supposed to figure out which curve is which. And you probably know by now, velocity is the derivative of position and acceleration is the position of velocity. So there's this relationship here. One of the graphs is going to be the derivative of another, and that graph is going to be the derivative of the third graph, but that third graph isn't going to be the derivative of anybody. So here are a couple of tricks and hacks that you can use. One of the most important is you look for the tops of hills and the bottoms of valleys, the very tippy tops and bottoms. So here's an example. I'm saying that right here, the blue curve is at its absolute minimum, right? It's at its very lowest point. And when you're at your minimum like this, your tangent is horizontal, right? Your tangent, if the slope of your tangent line is 0, that means that the derivative is literally equal to 0 at that point. And so check out this red curve. Do you see how the red curve is literally passing through height 0 at that point? So I'm saying that here, blue prime is equal to 0 and red is equal to 0. So I'm thinking that red might be the derivative of blue, right? And that's probably going to be the answer. But here's another example. So there's the green guy. His tippy top is right here. And his derivative is literally equal to 0, right? At this point. But where is his derivative? Where is the curve that's passing through height 0 at that place? It doesn't exist. That's kind of suggesting to me that the green's derivative isn't there. And so that's got me thinking that green is probably acceleration. So you can look for that. You can look for a curve that has mins and maxes, but there is no curve passing through height 0 there. And you're like, well, that guy's probably the acceleration. So let's look at this place right here between 2 and 3. And so here's what I'm seeing. The red guy, he's going through an absolute minimum there. The slope of his tangent is 0 right there. And the green curve is going through 0, height 0. So that's got me thinking that green is probably red's derivative. So I'm kind of hatching a theory here. I'm thinking that blue is position and I think that red is velocity and green is acceleration. But let me make a couple of other points before I finish up here. So you check out this region right here. Do you see how the red curve is going uphill? Uphill means positive derivative, right? Well, if uphill means positive derivative, check it out. The green curve is positive, but the blue curve is negative. So that says to me that blue is not the derivative of red. Similarly, if you check out this little region right here, it's going downhill. The blue curve is going downhill there, and downhill means negative derivative. And if the green curve is positive here, then green is not the derivative of blue. I just wanted to make the point that looking for mins and maxes is not your only recourse. You can look for areas and say, well, this curve is going uphill or downhill, and that means that the derivative is positive or negative, and try to put together the puzzle that way. So in any case, this is the answer. Blue, position, red, velocity, green, acceleration.